Okay. So now we will discuss the time required for the maximum height. So at one point the projectile reaches its maximum height and we have to find the time required to reach this maximum height. Afterwards the direction changes and it will go down. Till that point it was moving upwards, and after a particular point, that means after a maximum height it will move, it moves down. So we have to find out this the time required to reach the projectile from the initial point to the maximum height. So for that we are considering the Vy value, that is the velocity component or the vertical component of the velocity at the maximum height. You know that Vy is equal to V0 sin theta 0 minus g into t. For Tm, which is representing the time required for the maximum height. Okay, so Tm. Here, suppose if you are considering in between one point, the vertical component will be acting upwards. The Vy will be upwards and Vx will be horizontal. Okay. Here you can see that a further upward movement is not there at the maximum height. A further upward movement is not there. That means at maximum height the velocity in the vertical direction, that is Vy, which is acting upward, will be 0. The Vy will be 0 at the maximum height. Okay. So you can substitute the Vy is equal to V0 sin theta 0 minus gTm as equal to 0. The Vy value will be 0 at the maximum height. So whenever considering the Tm, the Vy will be is equal to 0. Tm is the time to reach the maximum height. At maximum height the vertical component of the velocity will be 0. So V0 sin theta 0 minus gTm will be is equal to 0, and V0 sin theta 0 will be is equal to g into Tm. Okay. So V0 sin theta 0, the g into Tm time minus gTm we are taking on the right hand side. So V0 sin theta 0 will be is equal to g into Tm. So then Tm will be is equal to V0 sin theta 0 divided by g. So this is the time required to reach the maximum height Tm, which is equal to V0 sin theta 0 divided by g. Now another time, that is the time of the flight. That means the time required for the entire motion from the initial point to the final point. Whatever the time it is required, that is known as the time of flight. So you can see that both the path, if you are just drawing a vertical line to through the maximum height, both the paths are equal. Okay. The upward path and the downward path are equal. So the time required for the upward motion will be is equal to the time required for the downward motion. So upward motion time, that is till the maximum height. So that means the Tm. So the time required for the upward motion till the maximum height, it is Tm, and that will be the same time required for the downward motion till the final point. Okay, till the final point. And so that will be the Tf, the time of flight, you can consider that one as 2 into Tm. 1 Tm from here to the maximum height, another Tm from the maximum height to the lower point. So 2 into Tm. So that value will be is equal to 2 into, that is the Tf. Time of flight will be is equal to 2 times that of Tm, and 2 into V0 sin theta 0 divided by g will be the value. Okay. That is time of flight, and this is the time required for reaching the maximum height Tm, that is equal to V0 sin theta 0 divided by g. We have started from the Vy value, and at maximum height the Vy will be is equal to 0. So V0 sin theta 0 is equal to g into t into m. Okay. Now we will discuss the maximum height of the projectile. What will be the maximum height of the projectile? 1 second. Okay. So the maximum height of the projectile. The height in the sense we are considering only the vertical component. The vertical component. It means the y component. Okay. So At the maximum height, the time you have to consider as the Tm. T will be is equal to Tm at the maximum height. So, whichever the value that you have just to derive now, that the Tm value, you have to substitute the value in the equation of the y. You know that y is equal to V0 into T plus half At A into T square. So, here y is equal to Hm, that is the maximum height. The maximum height, okay, the projectile and its maximum height that we have to find, that will be taken as y. At that time, the height will be Hm, that is equal to the y value, and the time required will be Tm. Okay. So, you are substituting the Tm here instead of T. So, V0 sin theta 0 into Tm, that is V0 sin theta 0 divided by G, and minus half A, that is minus G, plus half A, that is minus, where A is equal to minus G. So, minus G by 2 into T square. So, V0 sin theta 0 divided by G into G square, that is a Tm square. Now, here the V0 sin theta 0 into V0 sin theta 0 will be V0 sin theta 0 the whole square divided by G minus G by 2 into V0 sin theta 0 the whole square divided by G square. G will be cancelled, and you know that here the V0 sin theta square divided by G is common in both the cases. So, actually these steps are not necessary, but for your understanding just I am explaining like this. So, we are taking from the two terms we are taking the V0 sin theta square divided by G outside. So, here the 1 will be there and here the half will be there. So, V0 sin theta 0 all square divided by G into 1 minus 1 by 2, that is 1 by 2 V0 sin theta 0 square divided by whole square V0 sin theta 0 the whole square divided by G. That is the maximum height of occurred, or maximum height that can occurred by a that can reached by a can be reached by a projectile. Okay. So, these are the two things, the time of maximum height and the maximum the range, or sorry, the maximum height which can be obtained by the projectile. Now, we have to discuss the range of the horizontal range of the projectile. Okay. So, we will discuss the horizontal range of a projectile now. So, as a height, the maximum height, that was the maximum range a projectile can move in the vertical direction. Now, come to the horizontal range, that means on the horizontal direction or in the direction of the x axis, the maximum range which can be covered by a projectile. So, as we know, the x at a particular time will be is equal to V0 cos theta 0 into t. X is equal to the x component of the displacement will be is equal to V0 cos theta 0 into t. As we are considering the maximum range when it reaches, that means whenever the time will become the time of flight, that means from here begins, this is Tm, and when it is reaches here, that is Tf. That is the maximum distance a projectile can move, or the displacement can make from the initial point. Okay. That is the time will be is equal to Tf. Okay. Whenever the projectile covers this displacement, the time should be is equal to Tf. So, whenever you are considering the r, the range of the horizontal range, then the t will become Tf. Okay. The horizontal range, if you are considering, then the t value will become the Tf. So, you have to substitute the Tf when you are taking r, as r is equal to V0 cos theta 0 into Tf. For covering this much distance, the time required should be the time of flight, and that is equal to Tf, and Tf is equal to 2 into V0 sin theta 0 by G. So, in this equation, you are substituting the value of Tf, you will obtain the V0 cos theta 0 into 2 into V0 sin theta 0. that is 2 into V0 sin theta 0 by G, that is Tf, V0 cos theta 0 into Tf, where Tf is equal to 2 into V0 sin theta 0 by G. Now, listen, one of the trigonometric identity, that is 2 sin theta 0 cos theta 0 will be is equal to sin 2 theta 0. Remember this one, 2 sin theta cos theta will be sin 2 theta. So, you have to use that equation over here. So, cos theta 0, we are just taking the V0 combining, that is V0 square, and 2 sin theta 0 cos theta 0, that will be sin 2 theta 0. So, we on the numerator, V0 square sin 2 theta 0 will be there, that is V0 cos theta 0 into 2 V0 sin theta 0 will be is equal to V0 square 2 sin theta 0 cos theta 0, where 2 sin theta 0 cos theta 0 will be is equal to sin 2 theta 0. So, the final will be V0 square into sin 2 theta 0 on the numerator. Denominator, the G will be there. So, that is the range or the horizontal range of a projectile. So, you know that for getting the maximum range, the sin 2 theta 0 value should be 1. Okay, sin 2 theta 0 value should be 1. Then we can say the maximum range is obtained. If you are throwing that, suppose if you are throwing a javelin, it should be making an angle. The javelin will be making an angle 45 degree with the horizontal. Then it can reach the maximum horizontal range. So, the sin 2 theta 0 should be equal to 1, that means 2 theta 0 should be is equal to 90, sin 90 only, sin 90 is 1, so 2 theta 0 should be 90, so theta 0 value should be is equal to 45 degree, then only we can get the maximum range, and the maximum range value will be V0 square divided by G. V0 square divided by G is the maximum range. So, for that, for obtaining the maximum range, the angle should be kept as theta 0 as 45 degree. These are the major things regarding the projectile motion. Just go through the textbook, this is one of the important portion, and as well a uniform circular motion is also there, that we will discuss in the coming class. Okay, thank you.